12% of LLM tool calls fail. Not because the model is dumb, because turning English into executable JSON is genuinely hard, and one wrong token breaks everything. When you ask Claude to check the weather, it cannot browse the internet. Instead, it outputs structured JSON telling your code which function to call and what arguments to pass. This is tool calling, and it powers every AI agent you use. Here's the full loop. You send a prompt plus a list of available tools. The model returns a tool call. Your server executes it. You send the result back. The model synthesizes a final answer. 4 network hops per tool. You define each tool as a JSON schema. Name, description, parameter types, required fields. The model has never seen your weather function. It only sees this contract. This is how it knows what arguments to send. The model's job is to output valid JSON matching that schema. But LLMs generate text token by token, left to right. One wrong token and the whole call breaks. There's no undo. A typo in an enum value, a forgotten comma, an extra brace. The JSON parses or it doesn't. There's no partial credit. The validator is binary. Without constraints, 12% of calls fail parsing. The model hallucinates a field name not in the schema, misspells an enum, or forgets a closing brace. Your agent crashes. The user sees an error. 1 in 8 attempts dead on arrival. So the inference engine builds a grammar from your schema. It's a finite state machine that only allows valid next tokens at every step. Invalid tokens never enter the sampling pool. If the schema says Celsius or Fahrenheit, the model cannot spell anything else. The illegal tokens are masked out of the probability distribution before sampling. Invalid JSON becomes literally impossible to generate. The flow? Your schema compiles to a grammar once at the start of the request. Every token generation consults that grammar and masks illegal tokens. The output is guaranteed to parse because invalid JSON was excluded from the start. Unconstrained generation is fast but brittle. 12% fail. Constrained decoding adds overhead, but the failure rate drops to near 0. The trade-off is milliseconds for reliability. The overhead depends on schema complexity. Simple schemas with a few fields compile quickly, under 20 milliseconds. Deeply nested objects with many enum constraints take longer, but it happens once per request, not per token. The cost is front-loaded. Here's a real tool call to OpenAI's API. The tools array defines available functions. The model picks one and returns structured arguments. The API parses it and hands you a dictionary ready to execute. Agentic systems chain dozens of tool calls to complete one task. Search the web, parse the results, extract data, write a summary. Each call is another round trip. Each trip is another chance to fail. The complexity compounds quickly. Some agents now average 64 turns per task. That's 64 tool calls. 64 opportunities for a malformed JSON to break the loop. One failure and the whole agent hangs or retries. The error surface is enormous. When a call fails, you have 3 choices. Retry with the same prompt and hope the model gets lucky. Send the error message back and ask the model to fix it. Or abort the agent entirely. None are free. Each retry costs tokens and time. Self-correction adds another full round trip. The model sees the error message and tries again. If the schema was ambiguous or the error message unclear, it might fail again. You're back in the loop. The latency stacks. Every retry multiplies token usage and cost. A single failed call can burn 15 times the tokens of a successful one because you resend the entire conversation history plus the error each time. The context window gets expensive fast. The bill scales with failure. 3 retries means 4 full context windows sent to the API. At $1 per million tokens, a complex agent run can cost dollars per task when unconstrained calls keep failing. What actually goes wrong? The model invents a parameter not in the schema. It misspells an enum value like writing Celsius as Celsius. It nests JSON when the schema expects a flat object. It outputs a string when the schema requires an integer. Or it hallucinates a tool that doesn't exist. All valid JSON structurally, but wrong semantically. Your validator rejects it, the call fails. The agent has to recover. Here's a real failure. The schema defines status as a string. The model outputs it as a Boolean. JSON parses successfully, but your function signature expects a string. Your runtime crashes with a type error. The agent dies, no fallback. So modern agents use strict mode. The schema forbids extra properties that aren't defined. Types are enforced at generation time, not runtime. The model cannot output a Boolean where the schema says string. The constraint is built into the sampling. Invalid data never reaches your code. OpenAI's strict mode uses the same constrained decoding under the hood. You set strict true in the schema. You mark additional properties false. The API guarantees the output matches. The failure rate collapses. The full pipeline. Schema compilation happens once at request start. Token masking happens every generation step. Validation is automatic and invisible. Your code receives guaranteed valid JSON every time. The loop never breaks. The agent stays alive. The cost? Grammar compilation adds 20 to 50 milliseconds once per request. Token masking adds near 0 per token because it's just a bit mask operation on the logjits array. The overhead is negligible compared to model inference, which takes hundreds of milliseconds. Before constrained decoding, unconstrained calls were faster but failed 12% of the time. After, strict mode adds 20 to 50 milliseconds and fails almost never. The reliability gap collapsed. The speed gap is barely measurable. You win both. In practice, modern agents now chain strict mode calls without retry logic. The tool call succeeds or the grammar rejects it at generation time before it ever leaves the model. You never see malformed JSON. The agent runs clean and fast. But constrained decoding lives in the inference engine, not the model weights. Local engines like VLLM and SGLang support it natively. They compile your schema and mask tokens automatically. Allama and llama.cpp added it recently. Older API wrappers or custom servers might not support it. If your stack doesn't have constrained decoding, you pay the 12% failure tax and retry cost instead. The reliability problem returns. Check your engine. The grammar itself is a finite state machine compiled from your JSON schema. At each token position, the FSM computes which tokens keep the output valid. Those tokens stay in the sampling pool. Everything else gets masked to 0 probability. The model draws from what remains. The model can only sample from the valid set. Here's what the masking looks like. The model outputs logits for every token in its vocabulary. 50,000 candidates. The grammar marks thousands of them illegal. Their probabilities get zeroed. The forbidden tokens vanish from the distribution. Only the handful that keep the JSON valid remain. The sampling distribution narrows from 50,000 tokens down to a dozen or fewer. The model picks from that tiny window. Invalid completions were pruned before the dice ever rolled. The whole system. Your app defines tool schemas in JSON. The inference engine compiles them to finite state machines. The model generates tokens. The grammar masks illegal tokens at every step. Your code receives valid JSON. The agent never crashes on parse errors. No retries, no parsing errors, no runtime type mismatches. Quick recap. Tool calls are JSON generated token by token. Unconstrained generation fails 12% of the time because one typo breaks the parse. That's 1 in 8 agent runs dead. Constrained decoding builds a grammar that masks illegal tokens. The output is guaranteed valid. The cost is 20 to 50 milliseconds once per request. Strict mode makes agents reliable. The failure rate drops to near 0. That's the whole trick. The honest answer, agents fail because JSON is unforgiving. One wrong character and the whole call breaks. Constrained decoding fixes it at the cost of 1 grammar compilation step. The agent loop finally works. The 12% tax disappears. Turns out the real intelligence is a finite state machine. Like and subscribe for more honest looks under the hood.